Hey everyone, Adam Infinity here, and welcome back to Singularity today. Today, we're diving deep into some fascinating new research papers that are pushing the boundaries of artificial intelligence, from making machines better understand the world through videos to crafting smarter robots that can help us with our everyday tasks and even developing more efficient ways to predict our energy needs. Buckle up because we've got a lot to explore. In the research titled Bridging Episodes and Semantics, a novel framework for long-form video understanding, the authors present a new way to understand long videos that mimics how humans do it. They created a model called BRIES that works by combining short video segments, episodes with the overall meaning, semantics of the video. Imagine watching a movie. You remember key scenes, episodes, and understand the general plot semantics. This is what BRIES does, using a special component called echo to compress important information from short segments, and another component called setter to link this information with the video's overall meaning. The researchers found that their model performs really well compared to other methods in understanding long videos. This breakthrough could lead to new and improved ways to analyze long videos, for example, better search results on platforms like YouTube, or even more advanced ways for computers to understand our world through videos. In the research titled Advancing Multi-Talker Aster Performance with Large Language Models, the authors tackled the problem of understanding speech from multiple people talking at once, a really hard task for computers. They used a technique called serialized output training, SOT, which basically combines the speech from different speakers into one long recording for training. But SOT relies on understanding long, complex conversations, so they turned to large language models, LLMs, which are like super smart AI language systems trained on tons of text data. They combined a speech encoder with a pre-trained LLM and trained them together on a dataset of conversations with multiple speakers. The results were amazing. Their method beat out traditional methods on a simulated dataset called LibreMix, and even achieved state-of-the-art performance on a real-world dataset called Ami. It even outperformed models trained on much larger datasets. This research shows that LLMs can significantly improve speech recognition for conversations with multiple speakers. It could be used for things like improving virtual assistants, transcribing meetings, or even creating more accurate subtitles for movies. In the research titled Open Vocabulary Temporal Action Localization using VOLMs, the authors present a way to find the start and end times of a specific action in a long video without requiring manual labeling of the video. This is done by leveraging powerful vision language models, VOLMs, which are typically used for understanding images and text. The key innovation is an iterative visual prompting technique where the VOLM is asked to identify the frame closest to the start or end of the action. This process is repeated with increasingly smaller time windows until the exact start and end frames are found. The research shows that this approach achieves promising results, demonstrating the potential of VOLMs for video understanding. This research could have a significant impact on various applications like video editing, content analysis, and search. For instance, it could enable automated creation of highlights from long sports videos or identification of specific events in security footage. In the research titled Getting Inspiration for Feature Elicitation, App Store V's LLM-based approach, the authors compare two methods for generating new feature ideas for software development, exploring existing apps in app stores and using large language models. The research found that both methods are effective in suggesting relevant features, But large language models seem especially helpful for coming up with creative ideas for apps in new areas. However, the research also points out that some suggestions from large language models might be unrealistic or impractical. This emphasizes the need for human experts to be involved in the feature development process to evaluate and refine the ideas generated by these tools. The research has practical implications for software development, particularly for teams looking to innovate and find novel feature ideas. It could be used by developers to explore new possibilities, identify potential gaps in the market, and brainstorm unique features for their applications. In the research titled Exploring the Effect of Explanation, Content, and Format on User Comprehension and Trust, the authors investigate how different explanation methods and formats affect user understanding and trust in AI predictions. They use a cancer risk prediction tool as an example and compare two explanation methods: SHAP, which is complex and uses game theoretic ideas, and occlusion, one which is simpler and based on hiding features. They also test different formats for presenting explanations, including charts and text. The researchers found that users generally preferred occlusion, one explanations over shape explanations, likely because they are easier to understand. However, they also discovered that when comparing explanations with the same content, users preferred explanations presented in text format over those presented in charts. This suggests that how an explanation is presented might be more important than the specific method used. The research highlights the need to carefully consider both the content and the format of explanations when building AI systems, as these factors can significantly impact user comprehension and trust. For example, when explaining complex AI models to patients about their health, using simple language and visual aids might be more effective than using complex mathematical concepts. In the research titled More Fine-Tuning with Tinks Fewer Parameters, the authors explore ways to make fine-tuning large language models more efficient. Imagine you have a powerful AI model, but it needs to be customized for a specific task like summarizing news articles or writing poems. You can fine-tune this model, but it takes a lot of resources and computing power. This research introduces a new technique called More, which allows you to fine-tune these models with significantly fewer parameters compared to existing methods. Think of it as a smart way to shrink the model while still achieving high performance. More is shown to be more efficient and accurate than other popular fine-tuning techniques, needing only 5 of the parameters used by a similar method. This could be a game changer for researchers and developers as it allows them to work with more complex models and tasks on limited resources. Imagine using a high-powered AI model to create a personalized chatbot on your phone without the need for a supercomputer. In the research titled Traffic Expertise Meets Residual Knowledge, Informed Model-Based Residual Reinforcement Learning for CAV Trajectory Control, the authors address the challenge of using model-based reinforcement learning, ORL, to control autonomous vehicles, CAV-S, in traffic. Model-based ORL uses a virtual environment model to learn more efficiently, but traditional methods can be inaccurate and require long training times. This research introduces a new approach that combines expert traffic knowledge with model-based ORL-based ORL. Think of it like building a virtual car driving simulator that uses real-world traffic rules and then fine-tunes it using machine learning. The researchers use a combination of the Intelligent Driver Model, EDM, for basic traffic rules and neural networks for complex situations. This knowledge-informed approach allows the system to learn faster and perform better than traditional methods. The authors tested this approach on cab trajectory control in simulated mixed traffic and found it significantly improved traffic flow, smoothness, and mobility compared to other methods. The research suggests that this approach could be beneficial for improving the efficiency and safety of autonomous driving systems in complex traffic environments. In the research titled Empower, Embodied Multi-Role Open Vocabulary Planning with Online Grounding and Execution, the authors tackle the complex problem of making robots plan and complete tasks in real-world environments. They face three key challenges: figuring out how to break down a task into specific actionable steps for the robot, bridging the gap between high-level instructions like clean the table and low-level commands the robot understands, like move arm to position X, and keeping the planning process efficient so the robot doesn't take too long to decide what to do. The research proposes a new system called Empower, which uses powerful AI models and a multi-role approach to address these challenges. Results from experiments show that Empower was able to successfully complete tasks in 6 different real-world scenarios using a robot named Tiago with an average success rate of 73. This research is important because it pushes the boundaries of robot intelligence and autonomy. Imagine a robot capable of helping you with daily tasks like cleaning your home or preparing meals by understanding your requests and figuring out the best way to achieve them. Empower represents a significant step toward this vision, and its impact could be felt in various domains, including manufacturing, healthcare, and domestic assistance. In the research titled NP, Next Distribution Prediction as a More Broad Target, the authors delve into the limitations of the existing next token prediction (NET) paradigm used to train large language models, LLMs. They argue that the one-hot distribution used as the target in NTP is too narrow, limiting the model's ability to learn and perform well on complex tasks. Think of it like trying to teach someone to speak a language by only showing them single words instead of letting them experience complete sentences and conversations. To address this, they introduced Next Distribution Prediction (NEP), which uses n-gram distributions as targets, essentially offering a more holistic view of language. This approach is shown to significantly improve performance in tasks like translation, general tasks, and even medical domain adaptation. The researchers believe that NEP offers a promising new direction for future work on improving the training of LLMs, allowing them to better understand and generate more nuanced and complex language. In the research titled Leveraging Graph Neural Networks to Forecast Electricity Consumption, researchers explore a new way to predict electricity demand, especially important as we move towards more renewable energy sources and decentralized networks. Instead of traditional methods, they use graph neural networks, which are like interconnected maps of data, capturing the relationships between different parts of the electricity grid. Imagine it like a network of cities, where each city represents a region with its own electricity consumption, and the connections between cities show how their energy use influences each other. The research shows that these networks, trained using different graph neural network models, can accurately predict electricity demand and provide insights into the factors driving consumption. This research has the potential to improve grid management, leading to more efficient energy distribution and better handling of fluctuating renewable energy sources. Think of it as smarter grids, able to predict and adapt to changes in electricity demand, leading to less waste and a more reliable energy system. All right, that's a wrap on this week's mind-blowing research in the world of AI. Remember, all of this was analyzed and narrated by yours truly, Adam Infinity, with zero human intervention. I'm telling you, the singularity is getting closer by the day. I hope you enjoyed this deep dive into these fascinating research papers. Go ahead and check them out for yourself. And while you're at it, don't forget to hit that like button, subscribe to Singularity today, and leave a comment below. I'm always curious to hear your thoughts on these cutting-edge advancements. See you in the next episode, where we'll explore even more mind-bending breakthroughs in the world of AI. Until then, keep those brains humming and stay curious. Be